here? I see lots of answers, which is awesome. All right, let's see here. We've got C equals B greater than A, D, F, whoops, E. Abhishek, yours is written so small. A, B,
Just don't even look at her. No, you should.
It's card when you're not what we did.
That's okay. You know what? That's why we're here, right?
I don't know what's going on, but I wrote something down.
Gunners is dabbing.
It's an A.
Oops.
Yeah. Which one?
Wait,
Oh boy.
Courtney, I'm trying to write yours down. What does it say? I do.
Equals C. Greater than F and C. Yeah.
E
D,
equals MC.
A, C, D, F, E. I got you guys right. Did I get you? D, A, C, B, F, E. Oh, that's the same as this one. D, A, B, C, F, E.
Because it goes down farther.
Slightly lower than like.
Oh, right. Did I get everybody? No. E, C. Nick, I see your hand. Do you want to talk? Oh, you changed your answer. Did you write it bigger too? Oh. Come on, silly thing. Why is this being so goofy to me? Oh my gosh. Okay, I give up. There. Didn't you hear about the lottery is like how many millions of dollars because there's so many different combinations, right? All right, here we go. Yeah. I don't even know which one was yours. Do you remember? This one. D greater than, okay? Greater than B?
Yeah. And then
Equal to C like this?
yes.
All right. Okay, so we got lots of answers is really the moral of the story. Let's take a look here. We have velocity versus time graphs, and we're looking for displacement. How might one find the displacement from a velocity versus time graph, ladies and gentlemen?
Area.
Area, yeah? Area. So we're just going to count boxes, yeah?
Regret.
Okay, so that's what? 1, 2, 3, 4, 5? 5 whatevers. If we call this in meters per second and we call this in seconds, that's 5 meters per second. Is that right? Is that okay?
Yeah, sure.
You seem kind of mad at me there, I suppose. F is kind of similar in that it's a triangle, but it's like the same shape. So what's this one going to be? 2.5? Again, we're not worried about the negative or the positive. Now, if we think about this, just because this is, because I want to point this out, even though this was magnitude before, this one has a negative velocity. What does that mean about its displacement if we actually talked about the direction? We're going backwards, right? Does that make sense? Go, Niam. What's up, hun?
Yeah.
Oh, I do. I totally do. Thank you, hun. Thanks for catching that. Maybe I can erase it. There we go. And I totally mean 2.5 meters as well. Thank you. What about E? E is kind of funny. What's going on in E? It goes backwards, and then it slows down to a stop, and then goes forwards, right? So it's going slower and slower and slower, and then faster and faster and faster. What's the total displacement in E? 0 meters. That's kind of weird. What's that? Magnitude of displacement in terms of for letter E? It doesn't. That's a really good question. So let me address this. Please stop talking. Please, please, please stop talking. Okay? If you don't want to listen to what we're talking about, that's fine. But please don't distract from what we're trying to have a conversation about, okay? Put the water bottles away. I've already asked you once today. It's not hard. Okay. So your question was, does the magnitude part have anything to do with this one? So that's a really good question. So does it have anything to do? It does in the end, in that this one's still going to be 5 meters. Because in its travel, it's going to go 5 meters backwards. Does that make sense? But regardless of the magnitude of displacement part, this one is really going to start and end at the same spot. Does that make sense? So in the end, so this graph is different from, I think, let me see if this is the question you're asking, is different from a graph that looks like this. Is that kind of what you're asking? Yeah. So does that distinction make sense? So magnitude is kind of like, in the end, what does it look like? Yeah. Okay. All right. Help me out with the other ones here. So B and C are equalish. Some of you are fighting about C being a little bit bigger than B.
Yeah, it is.
Yeah, like a little bit, right?
It's a little lower.
It's a little lower. And then D is pretty big. So I think D is going to be the biggest, right?
Yeah, D's the biggest.
Yeah, this one's probably the biggest.
C is bigger than B.
And C is bigger than B by just a little bit.
Just a little.
So D, C, B.
It's D.
That's okay. I would call B and C equal. I think that's okay. Okay? I'm not going to worry about it. And then A. Did I mess it up?
Yeah.
Oh, that's embarrassing. Oh, it is DA. You're right. Sorry. CB. And then FE.
Yeah.
Okay. All right. I've got 1 minute to teach you something so you can do your homework. Are you ready? That's 1 minute, but you already know it, so I'm just going to tell it to you. Okay? Here it comes. Acceleration due to gravity. We've talked about it a lot. We'll talk about it and measure it tomorrow. Okay? So far, we usually are talking about things moving horizontally. It's just a car moving forward and backward, right and left, that sort of thing. But today and tomorrow, we're going to start dropping things. When we start dropping things, the nice deal is that the acceleration is always the same as long as you're near the surface of the Earth. Okay? On the moon or on Mars, it's going to be different. Okay? But near the surface of the Earth, okay, near sea level, the acceleration due to gravity is always going to be negative 9.8 meters per second squared. When you do the problems for tonight, they're all free fall problems. So the acceleration you're going to use is 9.8 in the downward direction. Have a great day, you guys. I'll see you today, later, or tomorrow.